Hello everybody and welcome to the second Hangout event in SC1x. I hope you are enjoying the course, and today we are going to talk about inventory management. Here we have Dr. Chris Kaplis. He's going to share his experience in inventory management. I hope you are enjoying the course. We're going to talk about today. We're going to talk about
So we're going to talk mainly about EOQ because I think that's as far as we've gone, the economic order quantity. So we'll talk more about that in a second.
Yeah. So Chris, I know that you have done a lot of projects in related to EOQ, not exactly EOQ, but can you share your experience with us?
Yeah, sure. So EOQ seems like the most contrived model. It's the simplest model, but it's exceptionally widely used. And the way I like to think about it is that it's a trade-off between fixed and variable costs. So when we get into other inventory models, whether it's anything with the stochastic demand, because we've assumed deterministic here, we'll always start with an EOQ model because it gives you a good sense of what your quantity should be. It's like Wikipedia. It's a good place to start when you're doing something. It's not, you might not end there, but it's a good place to start. So you'll see it widely used in almost every company because you use this to populate your ERPs for when you have a reorder point. We view it as a nice simple trade-off. It seems trivial, but it's widely used. I can't think of an inventory project that I've worked at with a company where we didn't at least start with that because it gives you a sense of things. Also, what it helps you do, and the way we came up with EOQ, right, take first and second order derivatives of the total cost equation. So that's the real lesson, the takeaway from the lesson here is that we developed a total cost equation that includes different aspects of inventory. And that total cost equation we're going to use for the remainder of the course. We'll keep adding to it. And so what we did here for the EOQ under very simple assumptions, deterministic demand, infinite time horizon, all those things, we're going to still use this same cost equation as we get to more complicated situations.
Good. One of the key features in the EOQ model is to define the cost parameters. So how do the companies define the costs?
Yeah, so this is boy, everyone does something differently. So I'd like to hear your experience as well, Ahmad. So you look at the big costs that you need to define. The purchase cost, that's usually pretty easy, right? The cost, the holding cost H, I think I talk in the videos. It's generally, you can think of this number in a bunch of different ways. You can think of it in how much space is used. You can think of it in terms of risk, in terms of insurance, obsolescence, all those kind of things. Overridingly, the H is given to you by the finance organization in your company. I think most companies view it as a hurdle rate. And so it's this, because for inventory, $1 I put in inventory is $1 I'm not investing in something else. So it's almost the investment hurdle rate. And it can be as low as 10% and as high as 25, 30%. And it all reflects the company's value of having inventory. What do they expect the rate of return of $1 of investment? So it really isn't as connected as people think to the product itself. To the like insurance value or anything. You can always add on to that, but generally the H or the carrying cost, the carrying charge, is a function of the company's perspective on risk. Some of the other ones, the cost of the transaction, that's actually very hard. Very few companies actually know the real cost that it takes to place an order. You can backwards calculate into it, but a lot of times what I've seen more frequently is that you know the order frequency, and therefore you don't need to know the cost for a transaction if you have an order frequency, because that kind of dictates one. But it's something that I've seen companies try and come up with, but it's a very fuzzy number because you're allocating fixed costs for a department, for personnel, over a number of orders placed. The easiest ones I've seen is when that cost per order is essentially the transportation rate, like the truckload transportation rate, where it doesn't matter how many units I put in there, it's a fixed cost. But that's one of the harder numbers to come up with that I've seen in practice. What have you seen?
Yeah, but, actually, you have the experience. So what I have seen is from the literature. That's good to hear from you.
Yeah.
But you said about transportation costs and shipping costs.
Mm-hmm.
Do they usually put this in the ordering cost, or?
We'll talk about this in week 9 or 10, but just as a precursor, because that total cost equation, so it depends how the cost is set up. So you can think of a transportation cost of having a fixed cost and a variable cost per unit. There's also a variable cost per distance, but forget that for now. So let's say I've got two types of transportation. One is like a bus where I pay per unit, it's totally variable. The other is like a taxi cab. I pay a fixed cost. So the fixed cost for transportation, that would go into the CT, the transaction cost. If it's variable, it would go into the cost of the item. So it depends on the structure of the transportation cost to where you put it. And that's what makes this cost equation so robust, is that you can fit almost any kind of cost in here. You just have to think about how is it being impacted. Is it a fixed cost or is it a variable cost?
Okay, good. And one more thing, the first 3 weeks in SC1x was forecasting.
Yeah.
And then we start inventory management. How do you connect these two?
Yeah, that's the challenge, because there's different ways you can teach inventory. And so I decided to come in with this EOQ first because it's such a cornerstone of inventory. In the week after the midterm, we'll talk about single period or news vendor problems, where we loosen the restriction of deterministic demand and we let it be variable, and we restrict things to be in one time period. Sometimes you can teach that before EOQ. Well, they both have to be taught, so it's kind of the sequence. So forecasting right now doesn't seem to have any impact on what you have for your inventory. It will have a huge impact later on, because when we go and look at the safety stock, right, the uncertainty, that's what safety stock's there. That is dictated by the variability in the forecast error, not necessarily the demand, but the forecast of the demand, how much my error is. That'll dictate how big or small my safety stock is. So right now it doesn't seem like it's connected. It's incredibly tightly connected when you get into variable demand, because it dictates the safety stock.
Yeah. Actually, for the demand forecasting, the demand is always forecasting is helpful. I know that you have covered this question, but I got this from one of the students that if we were 100% sure about the demand that we do have for next month, do we need to keep inventories? I know that you have covered for like level of service, you know, if we have enough inventory, like the fast food example that you gave. Do you want to?
Yeah, sure. So if I know demand next month is 100 units, the question is, I mean, obviously I need to have 100 units, right? So the question is, do I need to keep more than 100 units? For right now, in EOQ, because all inventory model makes assumptions, and if the assumption is that your demand is known and deterministic, like it's 100 units, we know it's going to be 100, it's never going to change, then no, you only need 100. That's why in the EOQ model we developed, there is no safety stock. However, if there's a slight possibility that there might be more demand there, or there's a huge penalty if there's any demand and you can't meet it, then you want to get into the question of, do I want to have a little bit extra? Or in fact, as we'll see in the week after the midterm, maybe a little less if the penalty of having too much is greater than the penalty of having too little. Think of buying buying Christmas trees. You can have too many Christmas trees right before Christmas, because the penalty of having too much the day after Christmas is huge. No one buys a Christmas tree after Christmas, right? And so it really is going to become a ratio, a trade-off between the cost of excess and the cost of shortage. And we'll get into that after the midterm. But for right now, if you know exactly that you're going to have what your demand is, then yeah, you don't need safety stock. And we'll see this again in SC2x when we do production planning, because in that time we loosen it up where your demand changes, but it's known in advance, and it's no longer an infinite horizon, it's finite. So I'm planning how much will I produce in October, in November, in December, and in that case you want to produce exactly what is requested. So if you're deterministic and you don't have uncertainty, then no, you don't need extra inventory.
One more question. How do you differ between slow-moving items and fast-moving in terms of inventory management?
So we'll cover this a little later in week 9, Because everything we're doing now, we're just barely tipping into inventory, and we'll get into more cases. But remember segmentation back in the first lesson, I think the first video of the first week, when we talk about A, B, and C type items, ABC segmentation. So everything we're developing for these inventory models are predominantly for B items, the lion's share, right? The A items we're going to do put special attention on, and the C items are the ones we don't want to spend too much time on. We're going to set and forget. So for the B items, we're going to come up with all these policies. Now for the A items, that's where you're going to worry about the fast and slow movers, because you can think of an A item, which means it's really important to you, in two ways. It could be something that sells very infrequently, but it's got a massive profit or revenue. Think of locomotive engines. You know, when you don't sell 20 a day, but when you sell one, it's a multi-million-dollar deal. Versus the other, where it might be something that's very low revenue, low profit, but you sell a gazillion of them, right? And so therefore, it's an A item. So you can get to the A item category in two ways: slow and high value, or fast and low value. Either way, you're going to be an A item. You'll treat them differently. And we'll get into exactly how, and it really goes into the assumptions of the demand distributions and how much time you want to spend on tweaking the parameters. And so we'll spend more time on that in week 9, lesson 1, I think.
Good.
I think that's where that is.
Good. One more question, maybe the last one before we go into your talk, and that's about the ordering policy. Cycle time or the inventory position? Which one is the most common use?
Usually the policy is determined, typically what I've seen, and correct me if you've seen something different, the policy reflects how much to order when, and that can take many different forms. And EOQ is very simple: order Q every T periods, or order Q when your inventory is at whatever, 0, or if you have lead time, the amount of demand over lead time, right? So it's pretty much says how much to order when. When we get into more complicated systems with variability, they'll get a little more complicated, such as if the inventory position is below little s, order to big S, and order up to quantity. And so there's all these different policies. The result of a policy will be the cycle time, right? They result from this. Your average inventory on hand, both safety stock and for cycle stock, are dictated by the policy that you have. So when you ask the difference between the cycle stock and
the
inventory position, you use the inventory position to actually capture this. And I think at the end right before the final, I give a talk that's not graded or anything. We give it right before the final exam that talks about some of the real world implications, because anyone who's worked with these systems, we look at lead time, for example, and lead time we say, okay, it's a deterministic value. It's 6 days, 3 days. In practice, it never is fixed, and it's never really known. In fact, a lot of times, if you're importing things for a manufacturer, you might have 2 different lead times. You might have an expedited track and a regular track, or maybe it's being sourced from multiple places. So the same SKU might have 3 or 4 different lead times that each of them might have a different distribution. So what do you use in your system? And so these are some of the complications that come in, and we'll get to those. What I want to make sure you guys understand first is how do the different trade-offs work? And so this is like the first step in building an inventory system.
Great. Today we are going to have a very interesting question for the breakout room, and I want you to give an introduction.
Let me lead into it. So can we go to the slides?
Mm-hmm. Okay, we're on economic order quantity.
Okay, go to the next slide. Mm-hmm. So just as a review, what are we doing here? So we're making some big assumptions on this, and the assumptions are that the demand is uniform and deterministic, lead time exists and it's deterministic, and then the total amount that you order will be received. And you see, it seems really simple, but it's nice to keep this in mind as we build more complicated models. We've got the demand is constant. When you place the order, you receive that order after a period of time. That's your lead time. And this results in that nice little chart, the sawtooth chart that shows the inventory on hand as well as the inventory on order. I think it's a dashed line on the slide that tells me the inventory position. And the position is what determines when I want to place my next order. So this results into the basic question, because all of this whole thing is lot sizing. And the question is, do I want to order a month's worth every month or 2 weeks worth every 2 weeks? That's really what it comes down to. And we're making a trade-off between the different costs. So what I have on this slide is the two inventory policies. They state the same thing. One is time-based and one is inventory position-based. The first one is time-based. I'm going to order Q star, that optimal quantity, every T star periods. Now that you could just build into your system. The other is almost a continuous review policy, where I'm always looking at it, and when the cost gets down to the amount of demand over lead time, right, then I'm going to place an order, right? So that's when two different ways of implementing the same policy. One is time-based, and the other is inventory position-based or event-based. Next slide. So the big thing we have here is the total cost equation. And so hopefully you'll get a tattoo that'll have this on your body, right? That says total cost is a function of your purchasing, your ordering costs, your holding costs, and your shortage costs. We'll use this throughout the course, and you can always add on to this. You might have additional handling costs. You might have additional customs costs. You can build a total cost or a total landed cost equation, and this is like the framework for it. The purchasing cost is straightforward. The ordering cost can confuse people that D over Q is simply the number of orders you're expected to place within a time period, typically a year. We look at an infinite horizon. We say per year, essentially. And then the third term, the ordering cost, will really expand this. Right now, the Q over 2 is simply the cycle stock. How much I order, it's that sawtooth, that triangle. And so we'll add to this later on with safety stock and pipeline inventory, and maybe some other types of inventory. But this is the variable cost of holding inventory there. The second term, that order cost, is the fixed cost. And then the final term, forget it for now, I just put it in there for completeness. We assumed it away that the demand is deterministic. Once demand becomes stochastic, you're going to get in there, you're going to have some kind of expected number of units short, some kind of stock out or shortage cost. And we'll get to that after the midterm. So at the end of the day, you have this simple equation, Q star equals 2 CTD over CE, which is the V times the H, or the cost of the item times the holding cost. You should know this backwards and forwards, and then T star is simply square root of 2 CT over DCE, and you can just figure the relationship there by dividing. So one is telling you how much to order. The T star is telling you how frequently to order. Once I know one, I know the other, right? I can't have two different ones. They are dependent on each other. So one of the things I think is really valuable is to just keep in mind what this equation is saying. It's not a law that came down from the mountains. It's just a relationship. So a lot of times in practice, as I was saying earlier, you don't know what the cost of the transaction is. What is the order cost? And so if I know how frequently they're ordering, then I can backwards calculate that and simply calculate or solve for C sub T if I know what's currently being ordered or if I know the frequency. And then you can use that as a reasonable test. Because I've gone into projects where they order something once a week because why not order something once a week? And you backwards calculate and say, well, by doing this, the implied value of your cost per order is $1,000. Does that seem right? And sometimes looking at in those terms, people can make better decisions. They don't think about it otherwise, but the implied cost there could be very high. So it's a nice, easy thing to do to backwards calculate what the implied parameter costs are if they don't exist. And we'll talk much more about this in week 7, I think, 6 or 7. We talk about more detailed inventory models. So what I want to do for the breakout groups is a simple question. We all can do EOQ now. We know how to define Q star, I assume. The question is, suppose that I have a SKU that can only be ordered in multiples of P units, and that's the pack size or the order size. So think about if I'm working in a restaurant, if I want like cups to order those, they come in packages of 1,000. You can't have one cup delivered to you, right? Eaches. So the question is, how does this affect the EOQ? Does it affect the EOQ if I have to order in units of, just say, 1,000 for these cups? How will this change the expected inventory on hand? And what are the trade-offs between having a large or small pack size? Should you strive to have a big one or a little one, and what are the implications? So this is what I want you guys to talk about, and then when we come back, answer these questions, and then we'll talk about it. Okay?
Great.
So go to your breakouts.
Okay, 1 second.